Hey everyone, welcome back to the channel and let's get started with the problem subarray distinct values. In this problem, we are given with the array of n integers and our task is to calculate the number of subarrays that have at most k distinct values. That means we should have till k distinct, not more than that. So for instance, if the size of array is 5 and we have to find two distinct values subarrays, then we can have either 1 or 2, not more than 2. If we have 3 distinct elements in a subarray, that is wrong. So for this array, the output is 10. Let's see how. So the first thing first, at most k here is 2. Can these single elements be a subarray in itself? Of course, yes. Because we can go up to 2, not beyond 2. So these single elements are a subarray with one distinct value. So this is a valid answer. So we got 5 from here. 1, 2, 3, 4, 5. Then this can be a subarray. This can be a subarray. This can be subarray. Then this can also be a subarray, right? The window is 2 and we have only one distinct element. So one answer is this, and the other window can be this also, right? The window size is 3 and we have two distinct values, this and this. So this would be, so 1, 2, 3, 4, 5. So the output is 10. So some things are clear from this, that we have to work upon a window. So we have to work upon a window, and we need to have something to measure the unique elements. So let's study this in this here. So since this is a window problem, we will have two pointers, left and right, and we need to do something when the window touches the required elements, or it crosses. So for instance, let's take the scenario in which the right pointer is pointing over here. We can see the window size is 2, and the window size is 2, and the window content are unique, right? So that means we can say in this window our answer would be, right minus left plus 1. So right is at index 1 position, left is at 0 plus 1. So that means we can have two subarrays, and we can clearly see that also. One is this complete and the other one is this. So we have two subarrays ending at this position wherever r is pointing. So this is quite a simple scenario. Let's take another scenario in which our left is here and somehow our right is over here. Now in this position we have size as 3. That means we can and the uniqueness is also 3, which is wrong, right? And we can't do simply like rl plus 1, right? Because 2 minus 1 plus 1, that is going to give us 2, which is wrong because of the question demands. We can't have 3 unique elements. We can have at most 2. That means we have to do something. We have to do some attack logic when the size exceeds our k. What we can do at that point of time is we have to remove the contents. So basically we have to remove the contents wherever the left is pointing, because this is increasing the size of the window, and this is taking the tail of the window. So that means we have to remove the contents wherever the L is pointing. So how can we remove? What would be the logic for that? Removing is whatever the count of the element wherever the left is pointing, we are going to decrease it. Why we are decreasing? Why we are not simply erasing it? The reason being, let's say if 1 is also here, that means this is a good window, right? But what you have done is, if you have erased everything, then this is going to be erased. We don't want that. Hence, we are not going to remove it directly. And if the count becomes 0, then we can erase, because that is not required in the window. The count is 0. So some things are clear from this thing. Is we want some attack logic when the size increases. We already seen how we are going to calculate the subarray. Now comes the next thing, which is the choice of container. We are storing the distinct element and we want to erase when the count drops. So we are storing the distinct elements and we want to erase the count. That means we can have hash map. Here we are going to store the distinct element, the size which we were calculating, right? The window size. So hash map size is going to give the window size, and we can have the count over here of the elements. These are elements and these are the counts. And when the count drops, we can erase it simply. So let's see what we are doing. We are having two pointers left and right, and we are having a container which is hash map. So our first thing is we add the current element to the window by putting in the hash map. So wherever the right pointer is pointing, we put it in the container. We add it in our hash map wherever the R is pointing. Then comes the attack trigger. We have to trigger an attack when the element in the window map crosses the k elements. We have seen this when the size is greater than the k, then we have to attack, we have to shrink the window, and when it crosses the window, we decrease the window, and if it drops, we erase it. And then we go on calculating the subarray by right and left pointers. So let's write the code, and then we will have a step-by-step understanding. Okay, so we have to calculate the number of subarrays, and n and k are given. So n and k added the input, and then we have a loop to fill the array, and then we call this function, and then simply we show it. So we calculate the size of the array, then we have two pointers left and right, then a hash map and a final result. So the first thing is we have to add this in our hash map. So we can have wherever the right is pointing, and we increase it. So we have did the input in our hash map. Then we can calculate is simple. We have the result with us. Wherever the right is pointing, minus left plus 1, and then we can, now we have to take care of the attack. This is where the main logic is. We need to calculate the size of the hash map, and if it exceeds the window, then we have to attack. We have to decrease wherever the left is pointing, and if count of left becomes 0, that means we have to remove it. We have to erase this element from the hash map. And don't forget, we have to increase the left also, and here also we have to propagate forward. So that means right has to be increased. So this is a simple logic. We add in the current window, we trigger an attack if it increases the window size, and we finally calculate the result. Let's try to submit this. Okay, it has been accepted. And okay, so this is giving, we can have a typecast over here. Basically the comparison operator here is integer and the long unsigned int. Because of it is giving this error. You can put a typecast to make this into integer.